Okay, that started. Okay, so are we together? Are we there? Hello? Are we together? Hello? Can you hear me?
Yes, we can.
Okay, I had dropped off, but it's recording now. So it's recording here. Okay, so we proceed. Am I audible? Hello, am I audible?
Yes, you are.
Okay. Okay, so we are creating stories now. So we say this is going to be the ground floor. So we can even name it as such.
Kindly share your screen. We can't see your screen.
Oh, is that so? Can you see my screen?
Yes, we can see it now.
Okay, so I said this is ground floor now. So we name it as such. Then this is going to be our first floor. This is going to be our second floor. This is going to be our third floor. Fourth floor. Fifth floor. Sixth floor, and finally seventh floor. Okay, like that, in that order. So we adjust the floor heights from here. So I would like our ground floor to be the tallest. Okay, so maybe we can give it what do you think, 4.5 meters, 5 meters, maybe 4.5 meters. Okay, so 4.5, then one, maybe 1, 2, 3 up to 4, we can have them at 3.5, 3.5, 3.5, 3.5, and then okay, maybe all of them, the rest of them are 3.5. So essentially our building is now going to about 29 meters high from the ground floor. Okay, now 29 meters high of a building. Okay, then we want to do 20% of foundation, just like standard. I know you can do just as maybe just standard. Say okay, 20% of the building height is foundation. So it's taking us to 6 meters, which is which we can say, okay, let's put the foundation at maybe 3 meters. Okay. Okay, let's put it at 4 meters. 4 meters foundation depth. Okay. Up to this level, we are all okay. We're all together.
Yes.
Okay. So I proceed to click OK. Okay. So I I remember Engineer Mshota Shura mentioning in one of the classes to say it's always better to start modeling from up coming down. Okay. So even the software itself will tell you after you're done with all your drama, let's start from the 8th floor to model whatever we are modeling, then come down. Okay. So we'll begin to model at this very floor, at the 8th floor. So we'll say, okay, we're going 8 stories high. So maybe let's pick maybe 450 by 450 columns, okay? We go to the modeling tab, we click on a column, okay? And then we're going to place a column maybe here, okay? And then we proceed to edit it. So we want it to be 450 by 450. Then we update, okay? Then we say, at this particular point, I'm just assuming how I would like it to be, okay? Maybe I may not even want to put a column here. I may put it elsewhere. It's just modeling, essentially. Okay, so maybe I want to put columns here. Okay, so I have 1, 2, 3, 4, 5. Those first 5 grids are populated. Those first 5 grids, remember when we were placing, we said 5 of them are spaced at 5 meters. Then there are these 3, which are spaced at 3 meters. Then there are these, which are at 5 meters, okay? So I'm going to put columns here as well. I think here, okay? And then I'm going to decide, so maybe I do the same here. Okay. Let me say up to this point. Let me do that. Okay. Then this side up to that point. Then let me leave this space in between. I'll proceed to the bottom. Let me leave these 3 grids. The ones that were 3 meters by 3. Okay. I'll leave them alone. Okay, let me populate this. Because the 3 ones start here. It's essentially 1, 2, 3. Okay. So let me populate this as well. Then I'll skip down to, so I'm leaving 1, 2, 3. So I'm going to skip to here. I populate this. So essentially everything that follows below here, I place a column there. Then I want to place some columns there as well. Okay, there. So now I'm thinking, why have I left these spaces in between here? Okay. So why have I left these spaces here? Let me do something different. Okay, go back to the modeling and let me pick a wall. I want to do a core wall. Okay, so I'm going to do a wall here up to this point. So I've started here. I'm coming there. Okay, then I'll put it like this. Then I'll put another wall here. So what I've done is I've created a staircase. I'm assuming there's going to be an elevator here. Okay. So if I have an elevator here, and then maybe let me have let me put some columns here. Okay. Okay. And then let me put some columns up to here. By the way, I'm just modeling here. I'm just doing what I'm. Yeah. Okay. So I think this is it. So I have a core wall there. Then I'll just say, okay, let me get rid of maybe these columns, because I talked about a shear wall, right? So let me do a wall, shear wall here, all the way up to there. So essentially, whatever drama is happening here, if there's going to have to be a door here or what, either you can provide a door through the shear wall or not. Yeah, then maybe let's do another wall here in the other direction. Where can we put it? Maybe here. Okay, let's put it here. Okay, so by the way, let's make the shear walls the same. So these are shear walls, these two, this one and this one. So we can come and edit section, and then we say, okay, maybe let me do this. Let me edit it from the properties. And let me say I want it to be 300 millimeters wide. Okay, that, then that one as well will be 300 millimeters wide. Okay, we're together, right? Yeah, I think we're together. Are we?
Yes, we are.
Okay, so even these ones, I make them 300, and then that one 300 as well, and then this one definitely have to be 300 as well. Okay, so remember now, this one on its own, it's a wall, it's together, and then this one is a wall on its own, it's a shear wall. So in both directions, so in this direction, what's the essence of having a shear wall? Say if you're going to have any lateral loading, remember this is a high-rise structure, it's 30 meters high. So if you're going to have any lateral loading, you want to lock all your columns to have a way of distributing their lateral loads to this wall. And then this wall will provide stiffness in this direction for the whole structure, remember, because we're going to have beams here. So this wall should provide sufficient stiffness for the whole structure in this direction. Then this wall should provide sufficient stiffness for the structure in this direction. Okay. Then the core wall, of course, should provide some form of stiffness in the center there. Now, my core wall here is essentially saying this is a wall on its own, this is a wall on its own, and this is a wall on its own. I do not want these to be individual walls. So Prota 2025 gives an opportunity to be able to merge these walls. So you highlight all of them, this one, hold down the control and click all three of them. Then right click, then you come to the part that says merge vertical members. So at a click, this becomes one monolithically cast member. So it becomes a U-shaped core wall. You're going to have a elevator shaft in there, and it's also providing stiffness in either direction as a core wall. Okay, so essentially what I've done is I've done a terminology that we call column bracing. So if I'm going to model a structure that does not have either a core wall or a shear wall, then all my columns should be analyzed as braced columns. But if I provide these three structures, then I can analyze my columns as unbraced columns. So meaning they only, if they are unbraced, then they only take care of axial loading. That's it. If they are braced, they transmit all the lateral loading from the wind, any lateral loading, they transmit it to the these structures, the core and the shear walls. Then all they deal with is axial load. So they'll just carry a load and transmit it down to the foundation. They won't be susceptible to lateral loading. Okay? Essentially, that's what this should do, provided there's connectivity among all these structures. So we've done our columns, right? Now I'm going to do a trick that I always do to avoid having a lot of columns in if I'm modeling a high-rise structure, to avoiding having columns at this floor, and at that floor. What I do is I highlight everything, all these columns. Okay, you can either highlight like that, but when I highlight like that, I've seen that I'm also holding these things. So what I do instead is to come to the floor on which I was modeling, which is the 7th floor. Double click it, then come to the column section. Okay, then it will show me a list of all the columns that I've modeled here, starting with 8. So I'll click the first one. So I'll click the first column, I'll click that one, then hold down shifter, then click the last one, then all of them are highlighted. So I right click, and then I go down to member tables. So on member tables, I come to column table. Okay, when I open column table, so what it's showing me is all the columns here. So I'll do the same thing I did the other side. Here on the length of the story, I click the first one, hold down shift, come down to the last one, and then I'm going to place now a number that sorry, I had to admit someone in, so I'll do that again. Okay, so I'm going to how many floors, remember, do we have? We have 8 floors, 8 stories. We have 8 stories. Okay, so I'm going to click 8 here. Now all of them will be generated to 8. Now what have I done? I have dropped the column from the 8th floor down to the foundation just by clicking this. So essentially, what am I doing? I want a continuous column from the 8th floor coming down all the way. That's why I've done this. So I close to be able to see the columns there. Okay, so that's the structure now, only the columns. Okay, so I go back to my plan view, which is this now.
Mundia, can you just go back a little? I didn't see that.
Okay, so let me undo. Okay, so what I've done is I want to highlight all these columns. I could highlight all of them like this, but I'm highlighting together with the grid lines. So the easiest way to highlight them is you come to the story on which they are modeled. So they are modeled on story 8. So you go under the columns tab, click the first column, hold down shift, and go and click the last column on this list of columns. Essentially what that does is it highlights all of them in between. So after they are all highlighted, and we can see in our viewports that they are all highlighted, the columns only, not the shear walls, not yet. So we right click on the mouse, right click, then it will bring this tab of options. So you go to the member tables. Member tables, it's the third from the bottom. So on the member table, it will bring another drop down. Then you go to column table because you are dealing with columns. By the way, this table gives you an opportunity to be able to apply certain properties to each structural element. So if you're dealing with members, by the way, so if you're dealing with beams, you can apply settings to them in isolation of the other members that are modeled in the structure. If you're dealing with slabs, you can also apply settings to your axes, columns, walls, reinforced concrete beam. Then in the steel modeling, you can do to your frame member tables and so on and so forth, even the slab and the rib slab. So, but we want to look at the column. So we click on the column, then it will bring this table. So this table essentially gives us a drop down of all the columns that we have modeled so far. So we come to this tab here, which says LEN, which signifies the length of the story, or the entire length of the story. So what it says is that these columns are only active in one story. Okay, that's why there's one there. They're only active in one story, and that story is the 8th story. It's the 8th floor. So we click the first one, hold down Shift again. Why? Because we want to click all the columns just in this tab. So we click the last one. So essentially, what we're going to do is happening to all the columns now on this floor. So what have we said? Instead of them being active on one story only, which is the 8th story, I'm going to make them active on all the stories. And how many stories do we have? We have 8 stories. So I'll just click 8 there. Okay. I click 8, then enter, then close that. Then the columns are now active in all the 8 stories. Okay, so these columns go all the way to the ground floor, to the foundation floor actually. Okay, so that's what we have done. So when you go now to your plan, you check on the 7th floor, there are columns. You can't see them, but they are there. Okay, go to the 60th floor, there are columns. All the way to the foundation floor, there are columns. Okay, so again we go to the 8th floor because we want to model now the beams. It's clear now, huh?
Yes, it's very clear actually. For me, I used to use the generate option, but this is very clear.
For columns, you don't generate, because if you generate, then you have maybe 100 columns on the 8th floor, 100 columns on the 7th floor, 100 columns on the... And then what that does is, when you begin to print out your reinforcement, when you go to design now, your reinforcement, you are going to have a cluster between steel coming from this story, clashing with steel from this story, and so on and so forth. So even when you click the generate, there will always be some extra steel. So this one gives you an opportunity to just analyze the column as one continuous member from the top all the way to the bottom without it interfering with other columns. When you do generate, you are saying there's a different column from the 6th floor to the 7th floor, and there's a different column from the 7th floor to the 8th floor. And those ones, when you are placing in reinforcement, the reinforcement will be placed in those ones differently. And then when you print it out now, where you say you generate as one, there will always be some issues with the reinforcement there. So this way is because for this way, even when... Okay, you have a question?
Yes, my question, this method that you've shown is very nice.
Okay.
How is it different from giving it a base offset? Like if you clicked one and then you offset it minus a negative so that it goes to a foundation.
Yeah. So I've not tried that one, but I think it can work similarly. It can work similarly. It can go all the way, but I think I'm familiar with this one, where like if I go to... Okay, the thing with the base offset one is you won't see that there's a column at this floor. Okay, maybe we try with one.
We can try, but I think it's similar. This one, I've never used it also. So you've taught me this one also.
Okay, great. Well, anyway, we'll try. We'll try it in another session. So for now, let's do the same to our shear walls. Okay, so we go back to 8th floor, shear walls. So we click those 3 again, and then right click, member tables. Now we go to wall table, because these are walls now. Wall table, and we'll find them. They are here. So what we'll do with them is we'll come to the same length thing, and then click 8. Yeah. So then those walls are done. Then we come to this one now. And this one is analyzed as, because we merged them. So it will be like what? Will it be a okay? Let's your method. Let's use your method here. So we are saying it's at how many floors? Okay, let's come here. So 29 meters, So let's try and do minus 29. Let's see what will happen. I'm using your method now, short. So
Okay.
yes. Wait, okay, let me do this. What I'm going to do now is I'll just unmerge them. I don't want us to experiment with Mishatas. I'll just unmerge them, have them behave like walls, and then merge them back again. So you've seen what I've done there. They've gone. Then I'll merge them. I'll merge them again. Then it becomes one more. So I've done the same thing.
How did you unmerge them?
Remember, I merged them at the beginning. So you just click it. Then there's this here, unmerge vertical members. So you click on it. Then they become unmerged. They become isolated. This is on its own. This is on its own. This is on its own. You see here? So you want to merge. You click one, hold down Control, then click all of them. When you go back to the same item, it says merge. So if your Prota doesn't have this icon here, you can just right click. Right click, come down to, there should be a merge vertical members here. This one here. So you merge, they'll be merged. Becomes one member. Okay? So we come back to plan now. Okay? So we are now dealing with beams now. Okay, so we go back to the modeling tab. Beam. And then we place a normal beam here. Yes.
Before we go to the beams, I have a question on the columns.
Yes, sir.
Okay, so you said we are having the same column from the ground level up to the last level on top there.
Yes.
So my question is, in terms of reinforcement, because most of the structures I've seen, even Mr. Shapira can attest to, when we were at the King's Hospital, we had bigger reinforcement on the, I think, ground floor, and on the top floor we had smaller reinforcements.
Yes.
So now, if we're having the same column from the ground level up to the top level, how can we solve that?
We can always reduce. So if we're reducing now, then we'll use the other aspect where we say, okay, we want to do the same type of column, maybe from the 4th floor going down. So I'll start modeling on the 4th floor. Then I'll come and model another column on the 8th floor, which is maybe 300 by 300. And then I'll drop it 4 floors down. So there where I was clicking 8 on the column tables, where I was clicking 8, I'll click 4. So essentially what I have now is I have 2 types of columns. There's the 450 by 450, which starts from the 4th floor down to the foundation. And then there's another one which is 300 by 300, which starts from the 8th floor down to the 4th floor. I've done the same thing, only that in the way I'm isolating the columns, I'm not repeating the same type of column per axis or like per story. I'm taking consideration of the fact that, look, this same type of member or a column, same size, is repeating for maybe 4 floors. So I don't have to do it on floor number 4, come and do the same again on floor number 3, the same on number 2 and on number 1. I can just do one on number floor, then drag it to the foundation. Then the different type, if the different type is starting from number 6 to number 4, I model it on number 6, then drag it 2 stories down to number 4. And then do the last type, maybe which is a 250 by 250, from the 8th floor and drag it down to story number 6. I don't know if that is clear.
Okay, that is clear. I hope we are going to do this in this video, in this course.
Okay. Yeah, it's possible to do that. Anyway, we can be able to model something applying the same things, the same thing that we're talking about. Even in this one, we're able to do that, as long as it's okay. It's the same system. Okay. Even okay. Say for instance, let me do this. Let me do that maybe for these columns here. Have you seen these columns? The ones here. So I'll get rid of them. I'll get rid of them here. Okay. So I delete them. Okay. So what I'm saying now is that I'll go on which story? I'll go on story number 4. Then I'm going to do a column, which is what size? 450 by 450. It's starting at this level, going down to the slab, to the foundation. So I'll do the same kind of placement I was using, which is highlight, and just highlight around this area. Then it will place the columns on its own. Okay. So when I click these columns, when I highlight them, you are seeing what's happening. Huh? When I highlight them, then I right click. The same thing I was doing. Right click. And then go to the member tables under column tab. I'm only focusing on these columns. So I'll say, okay, let me allow their length to go only 4 stories down. It's already automatically picked because of what had happened there. So it's saying, okay, it's just going to go for 4 floors from the 4th floor coming down. So it has already picked that. So even if I come here in 3D, you can see these columns here. Let me actually pick them. Let me highlight them. You can see them in 3D. They are here.
Yes.
They are only starting from the 4th floor coming down. So what do? I go now to the 8th floor. In plan, I go to the 8th floor and model a different type of column. You see, they are not present here. So if they're starting from the 4th floor, on the 5th floor, you won't see them. On the 5th floor, you won't see them. 6th floor, you won't see them. 7th floor, you won't see them. So let's model them on the 7th floor, but a different size of the column. This time not a 450 by 450, but let's do a 300 by 300. Okay. Update. Then let's model that column there. So where have I modeled these columns? On the 8th floor. But remember that on the 8th floor, there are other columns which are big. So in highlighting, I won't highlight all of them in here. I can click them one by one based on their difference in dimensions, in size. So I click them. I also know their localization where they are. Then right click, go down to column tables, go down to column. Then I'm looking at these. They are also going on how many stories? Only 4. But I can twist this and say, okay, because I know the blank space is from story 8 down to story 4, and that's 4 floors. I can twist this and say, okay, I don't want them to be on 4 floors. I want them to be on 2 stories only. That is the 8th floor to the 7th floor, 7th floor to the 6th floor. So I'll place 2 there. Enter, close. So what I have is that they are only in this region. So there are 2 floors here without columns. You see? So they are only on the 8th floor here in plan and on the 7th floor. If I come down to the 6th floor, sorry, to the 5th floor, so these columns are where? They are here. Okay? Let me highlight them. I modeled them on the 8th floor. 1, 2, okay, there, right? So these columns are only on these 2 floors. So if I want another type of column again to be acting in this same region from there down to, something went wrong.
Can see you.
You can see me? It had hold on.
I think it was a network issue on your end, but I can see you.
Okay, yeah. So I was saying they are there like from the 7th floor down to somewhere on the 5th floor. So we're coming to put now a different type of column. Okay, so maybe this time around let's do a 400 by 400, and then we put it here, and then these ones, remember we're putting these on the 6th floor. So column table, then they are only for 2 stories, so meaning from the 6th down to the 4th. Okay, so now even when we look here, we find these are populated now. So there's this type of column which is from 6th to 4th. Then there's this type of column which is from 4th down to the foundation. Then lastly, there's this type of column which is in sorry, let me click the last one. How will I, okay, yeah, then there's this one which is from the 8th floor down to the 6th floor. So these ones are of different sizes. This one is 300 by 300. The next one is 450 by 450. Wait, this one is, actually I didn't even change the sizes. Huh? Okay, I meant to change the sizes of these ones. Let me change their section, edit section to what? 300 by 300. Uh-oh. 300. Okay, so these ones have become smaller now, you can see. So this one is 300 by 300 sitting on these ones. So these ones also I can change them. The ones that are starting up. 5th floor. They are these. These are the ones that we've accepted to be 300 by 300 down to where? Then let's change these ones. To 400 by 400. Edit section. 4 zari by 4 zari. Okay, yeah. So you have 300 by 300, 400 by 400, sitting on 450 by 450. So that's what I was explaining. Is it clear now? I can't remember the one who asked.
Yes, it's clear now.
Yeah.
It's clear.
Yeah, so essentially,
So now,
like
how is
at the
the load
King's Hospital,
transmitted?
at the King's Hospital, you can have now column sizes change now. They are changing. Why? Because you know that as you are going up, you're going to be having less. You know how the column behaves. Huh? The axial force that is on top, on the 8th floor, like after the 8th floor, which is the roof floor, brings the axial load on the column. That axial load, if it's 10 kilonewtons, okay, whatever axial load has been generated from the floor now on the 7th floor, plus that one. So if we have now from the 7th floor, we have another 10. So we have 10, 10. The 7th floor to 6th floor column will be handling 20 kilonewtons. Then the 6th floor to 5th floor will be handling 30 kilonewtons, and so on and so forth, until by the time you're on the bottom of the foundation, you have like 160 kilonewtons, or is it 80 kilonewtons, which is being taken to the foundation. That's how they behave. So that's essentially why, like he pointed out, to say at the King's Hospital, we noticed that as we were going up, the columns were reducing in size. That is the reason why they were reducing, because the building is loaded from up coming down. So from up, it has got minimal axial load acting on it. As you go down, it's essentially taking its own axial load together with what is coming from above. It's handling that, transmitting it down. Then the third one is handling its own axial load from the floor plus the two other floors on top. Yeah. I hope that's clear. So should we proceed to beams, or we do beams tomorrow?
Very clear.
Senior
Very
engineer.
clear. Very clear. So now,
Senior,
just based on this concept, can you hear me?
yes, I can hear you.
So because we've got those 300s that are on top, then we've got the 400s in the middle, then the 450 at the bottom.
Yes.
The concept of that, the actual loading that you've explained, will it be evenly distributed on the surface area? Because for a 300, it will be, obviously, these columns, they are there's no eccentricity.
Yes.
They're at the center.
Yeah, they're at the center.
And then for a 300 resting on a 400, you've got those spaces around.
Yes.
So what happens to those spaces? It will be distributed on the surface everywhere there.
Yes. So that loading will move in form of stress through the reinforcement. So if it's being transmitted from the reinforcement above, that's why when we lap like that, the stresses, it's axial, so it's down, up, top, coming down. So the stresses are transmitted from the top reinforcement into the bottom reinforcement, and they go down like that. As long as the cross section of the column, that's the concrete, as long as it's stiff enough not to squash or fail, then it will just transmit whatever stresses are generated from the loadings. It will just transmit it coming down, 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 down to the foundation. So that's why there's that concept where we say the column should be able to carry whatever it's carrying and just transmit it down without it being affected by whatever has been imposed on it. So the resistance should be more than the the loading, so that it doesn't fail. Because the moment it fails, then we have to now we have to pray now that there's some redundancy somewhere. Redundancy being one member in a structure can fail without jeopardizing the entire structure. So as we design also as structural engineers, we're supposed to design for redundancy, where we say, okay, in an event that this column fails, the whole structure must not come down. or if the column continues all the way to the basement and there's a basement parking. So if a car accidentally hits that column and it fails, the whole structure must not come down. So the structure must find its way of redistributing whatever axial load was coming there. It redistributes it to some other column nearby, and that other column should be able to handle it. So it's some form of over-designing, but that is beneficial, and it's in structural terms it's referred to as redundancy. Without redundancy, we're going to have progressive failure now, where just one failure affects the whole building and everything comes crashing down.
Race Peter.
Peter. Yeah, so should we proceed to the columns or to cutting the mile? This is 2155.
It will depend on you. If you feel like you can proceed, you can. We end on beams. If you've got anything else that you need to do, then we can end it here.
Okay, maybe we can do the beams and generate. So we go to so we go to the 8th floor. Okay, so on the 8th floor, we'll take note that here we have these type of beams. We have these types of columns. So we can either overload it by putting a beam that is wider than the column. Columns can handle that. Or we just follow the cross-section of the column. Okay. So when we do the beams here, in this zone, we can just come and say, okay, let's do a 300 wide beam, maybe by 450 millimeters deep. Update. Then we do that here. Okay. So we've done those beams there, and even here we do the same. I like to put the beams like this. Like if I start with the horizontal, first I put them so that there's continuity. Drawing, when you print out your drawing, it doesn't look nice where you have like 1B6, 1B48, 1B8, 1B19. It's better if like they're continuous, especially that you know your limits. You know that, okay, this is going to be a continuous beam. So it's going to be 8B5 followed by 8B6 followed by 8B7 and so on and so forth. So if you're starting with these types of beams, so you know that, okay, on grid A, I have continuous beams, and then from where it terminates on grid A, it continues on grid B, and so on and so forth, even as you print Philamoneka. Yeah, so then when we come here now, we can change the cross-section here. Okay, so the beam that we put here now becomes 450 wide by 450. It can be a square beam, no problem. So here we have another beam there, then we have another one there, then we have another beam there, then we have another continuous beam there. So my assumption is that this part will be left open. Okay, that's my assumption of this structure. So then I'm going to have a beam that is running from there. By the way, the beam won't continue over a wall, so it will terminate on a wall. So this one, I'll terminate it here. Okay. So this one, I'll terminate it here. Then I'll run this one up to here. Okay, this one can continue because it's just resting on that wall. Then this one can continue up to there. This one will continue up to there. This one will continue up to there, and so on and so forth. We move to the other wing of the building. So now the building is looking like an H building. So my beams are over designed. You can't have a 400 by 450 beam on Pamurupadi. Okay, I can terminate here. Then I have another one there. Otherwise, I'll be. You know why I'm not putting a beam over here? I can do it. I can put a beam here, but it will overlap. That's one. I can do it. There will be a beam there, but it will overlap. And remember, in a wall, there's vertical and horizontal reinforcement. So this is like a repetitive thing to do. So I won't do it. So I continue with the beam. This zone. Then I pick up these guys here up to there, and these up to there. Then okay, up to there, up to there. So it's game patience. I don't know, but when we come to generate, it will look proper. So now that we're done with this, then I use the same type of beam from this point coming down. This for here. Oh, this is what I can do. Just for purposes of the beams looking continuous. Okay, I've put beams there. This type of beam is what I want. So then I come and have this edited section 300. Okay, then I do a continuous beam now because I know this runs. Okay, let me put here first. Okay, then I'll come and put here. Okay, then I'll come and put here. I'll end here and then continue from here down to this point. Then I'll go all the way. Okay. Then I have these guys here ending here. Then I have these guys here. Coming down to that point. Yep. So here I'll decide what I'll put here. But maybe let me just do the needful. By the way, this modeling is just for illustration purposes. I know you would not. Some points you would not have to put like here. These things are too close to each other. You can't put such ridiculous beam sizes. Okay. And then we have the last beam, which is here. Okay. So essentially what we have now here is that we have modeled this. We have modeled beams on that floor. So we are able to generate the same type of beams all across up to the bottom at this particular point, or we can put slabs first. So maybe what we can do is, let's just model so that it looks like a framed structure. Let's just generate. Okay. So in generating, what we'll do is we'll come down to this same beams on the 8th floor, by the way, so that we highlight all of them, right? Hold down shift like that, so they are all highlighted. Then they are all highlighted now. So then right click and say generate to other stories. Here there's this option here, or you can go to the building setout arrangement. So the way I've highlighted them here is I'm just localizing the generation only to the beams that I've highlighted. So generate to other stories. So I'm starting from the 8th floor, so I'm generating to the 7th floor. I say generate, then to say done soon. Should say, why is my computer slow?
I'm also surprised. I'm watching here, it's lagging. It's an alien way. You are the one we fear, my friends.
I need to switch it off first. Usually by now it should have generated.
So I'm planning to get an alien way. But competition is coming.
Get an alien way. Okay, completed. Okay, so we go to story number 6. Okay, completed. Icho. Chiwera nomba mu speed. Icho. Okay.
You guys are very funny, yeah?
Yeah. Wait, what is happening? It's not generating. Oh, I haven't clicked. Yeah, I come to story number 7. Let me use this. So I've used this type. Let me show you this side. I come to generate, because we talked about this. So generate. So we're starting from story number 7. We are deselecting everything and only selecting beams. So whatever beams are on 7, we are putting them on 6. Done. So whatever beams are on 7, you could pick the same 7 and take them to 5, or if you like, you can come to 6, take to 5. 5, take to 3. Whatever, it's the same thing. So take to 4, generate, take to 3, generate, take to the first story, generate. To 1, we won't generate anything, because if we generate a story on 1, it's going to be the ground floor. There's a slab there. So we just leave these like this. Anyway, we can even generate and have them act like plinth beams. Let's generate. Yeah. So close.
The egg class.
Now we have this structure here now. It's looking like, what Shan is that? Isn't it Minister of Finance? Something like that. Yeah. So at this point, we're even able to analyze because all the stories have been populated. Okay. But if we want to rush to analyze, we have to model the slabs. Okay. So
Where is Ministry of Finance?
the one along Independence Avenue. The one opposite the man there for the president.
Oh.
Doesn't look like this.
But this connection, I see the link bridges there. Looks like the BOZ.
Oh, why?
Isn't
Yeah,
it?
this.
You're linking. That's the access from one
From
building
one
to the
story
next, isn't it?
to the other, yes. So essentially what we can do, another thing that we can do is we can do another stair, whatever here, another core here. So that we have two staircases.
And then these shear walls, these core walls are for the elevator?
Yes, they are for the elevator. So we can do another one here. That's modification that we can do to it. So we can do another one here for another stair, whatever. Then in between here, these two can be staircases from floor to floor. Then we just look at what I'm thinking. We can even cantilever out this thing. So when you're coming from the elevator, you are just on a cantilever thing, like cantilever, maybe 2.5 cantilever slab. Okay, 2 meters. 2 meters cantilever slab. So you're coming from the elevator, you're just seeing glass, and then you're moving now this way to the wing or that way to the other wing. That's where activity is now. Why, Monaca?
Want to model the staircases using glass?
No, not the staircases. A deck. See, because look at it this way. Okay, let me illustrate it. The easiest way is to illustrate it.
Slab.
Using a slab. So, let me say this I offset by 2 meter. Then this I offset also by minus 2 meter because I'm going down. Okay, so what I will have now is model a slab. Okay, I have to put load cases. Okay, and then horizontal, let me put some wind there and apply notional load to it. For now, just that. Okay, so my cover, let me change it to 30 mm. Let me have a 200 mm slab thick because it's a cantilever. I can even do 250 or 275. King Salman was what? Wasn't that 375? What was the depth of those slabs? 275, huh? Let's do 250 mm. Loads, let's treat it like a balcony. And then let's use 2.5 of imposed load. Okay. So it's cantilever. So it's supported on one side, and then on the other side it's cantilever. Okay. So bar. Okay, it's beam region, so let me click points.
It's not to be very big.
It has to be very thick.
I can't remember, but I think so.
Da. Okay, so it's like that. Then even this side, you have something like that. You have something like that. Then we'll change the slab type back to all supported. Number 1. Then fill up those. Okay, let's put around this whole area. Okay, so this is what I was talking about. So if I'm generating this thing now across all, okay, I'll just use this one. It won't do, so let me go there, generate from 8 down to 6. Hey, I almost caused the disaster. I almost forgot to unclick certain things. And story number 1. Okay. So ati, so wamona what we are doing. Alef mamchukwepe aingira hapa. So this thing is cantilevered. So hapa epa ni risky hapa. Hapa epa ni risky sana hapa. Hapa, but it can work because now monoka.
Mundia, so this is like the landing after this. This is
Yes.
what people used to move now. It's like
Yes, it's like the landing after from here. It's a landing. Then here there are staircases here. So this is the entrance. Aingira omuntu. Either are bomfye chikwepe or are bomfye stairs.
So it's all the way down.
All the way from down going up. Then this whole part is covered with glass. So that umuntu taponene pansi. But
can you hear me?
Yes, I can hear you.
Very interesting.
This whole part, this whole facade, the facade here is glass. But there are no columns whatsoever, no nothing. So it's just a suspended slab here that is anchoring into this space here. So if we wanted to be industrious, we would do. Yeah, if we wanted, we would actually extend these beams and bring them out to flush with here, so that they provide extra, so that they become like overhang beams. You get this beam will be continuous this way and that way, so that they provide strength to this. But even just like this as a slab, if reinforcement is starting from going all the way up to there, it will be stiff and it will hold. Yeah. So then this wing is another maybe building. Then the other wing, another building. They are all accessed through here. Then now, what we could also do is say, here we put a fire escape here. And here we put a fire escape. It has become a fully serviceable building. So we'll finish modeling it. And we'll analyze and design it. I think for now, we have at least done something on it. So it's work in progress. I think in the next 4 or 5 days we can be done with this one.
what I said, what the valley.
Ati? Ashano chikokolo. Oi. Gentlemen, can you hear me? Oh, there's a lady also here. Or it's just gentlemen? Okay, so guys, I think I'll proceed to. Wechibokolo. Mweba pondoni mwevo. Mweba pondoni mwevo. So I'm stopping the recording.